Yeah, in this video, we're going to talk about the graphs of sine x and cosine x and all of the different transformations and translations and reflections that we've done previously for other graphs also are done with sine and cosine graphs, but it all starts with knowing just your basic graph of, let's start with y equals sine of x, and then we'll do cosine x after this. So what we could do now to graph this is just pick some x values, some angles that we know how to find the sine of using your special triangles or using the unit circle. Here are some angles and the corresponding sine values. If you're not sure how to find those, go back and watch the video on special angles. So then we're going to plot these. So x, now we're going to put that on the x-axis. These represent our angles, and the y value is going to be the sine of those angles. So one trip around the circle, as we know, is from 0 to 2 pi. We're going to see how this looks graphically if we graph it on the xy plane. So here's 2 pi, here's pi. Halfway between 0 and pi is pi over 2. And this would be 3 pi over 2, halfway between pi and 2 pi. And pi over 6, pi over 4, pi over 3, these are all in between in the first quadrant if you're thinking about the circle between 0 and pi over 2. Pi over 4 is halfway in between, that's 45 degrees. Pi over 6 is 30 degrees, that's not quite half, it's more like it's a third actually of 90 degrees. So this would actually be pi over 6, pi over 3 would be about right there. And if we just start, when x is 0, y is 0, so that's going to be at the origin. When x is pi over 6, my y value would be 1/2. I'm going to make this 1/2 right here. Pi over 4 is it's root 2 over 2, which is about 0.71. So if this is 1/2, it's just a little bit bigger. When x is pi over 3, I get root 3 over 2, which is about 0.87 on a calculator. So that's almost 1. And then by the time we get to pi over 2, the value of sine is just 1. So this tops out at 1. So I included some of the angles in between 0 and pi over 2 just to show that graphically, while we're at 0 when x is 0 and we're at 1 when x is pi over 2, it's not a linear. You can tell this is not a straight line relationship. It's going to look more like this. And then you could do the same thing and pick a bunch of angles in between pi over 2 and pi with using reference angles of either pi over 6, pi over 4, and pi over 3. And what you're going to find is you're going to get the same kind of curvature as the graph goes down to. By the time I'm at pi, the sine takes on a value of 1, but it's going to look identical. So this will curve down, go through 0. By the time from pi to 3 pi over 2, the value of sine is -1. Same thing, it's going to curve kind of in the same way it curved in the first quadrant. And then by the time we get to 2 pi, which if you think around the circle, that's one trip around the circle, we're right back to 0. Now, just like when we talk about trig on a circle, you can go around the circle as many times as you want. We can keep going past 2 pi, and what we're going to see is this graph just continues the same pattern. It's going to go back up to the top here, and then just continue to look like this. And we can go in the negative direction too. If we went this way, it would look the same going backwards. Okay, so we get this, some maybe familiar to you, some sine kind of a wave graph. And so, but one trip around the circle, most of the time we're mainly just concerned with the graph between 0 and 2 pi. So here's what the graph would look like. So notice that, as I was mentioning, the graph's just going to repeat itself from 0 to 2 pi. If I kept going from 2 pi to 4 pi, it's just going to look the same. And from 4 pi to 6 pi, it's just like going around the circle multiple times. You're just going to get the same graph as you do that. So we say that the period of y equals sine x is 2 pi, because if I go from 0 to 2 pi, I've completed one cycle where it's gone up, back down, gone down, and then right back up to the x-axis. And if I kept going, it's going to do the same thing. So this distance from 0 to 2 pi, that is referred to as one period of a sine graph. And it's 2 pi. So yeah, I was going to illustrate that here, that if you did graph it between all the way to like 6 pi, which is like 3 times around the circle, what you would see is the same kind of graph where it starts at 0. And then if this is pi over 2, it goes up to 1, back to 0 at pi, down to -1 at 3 pi over 2, and back to 0 at 2 pi. So this is the graph we just sketched. And if you kept going, it's just going to do the same thing. And I like to think of a sine or a cosine graph in terms of high, middle, and low. The highest value a regular sine graph will ever get to is 1, and I'm going to use H for high. The middle, where the graph is kind of oscillating around, is 0. I'll use M for middle. And my low is -1. That's the lowest value the graph ever takes on. And so one way to think about the graph of a sine function is it starts at the middle and it goes middle, high, middle, low, back to middle. And then we're just going to continue the process. Middle, high, middle, low, back to middle. There's another period of the sine graph. Middle, high, middle, low, back to middle. So right here, I have 3 periods of the sine graph sketched. Notice too, you can also, I'm measuring, I described the period as starting at the middle and kind of ending right here, but you can also measure the period, for example, between 2 peaks of the graph. That distance right there from pi over 2 to this would end up being 5 pi over 2. That's also 2 pi. That is one period as well. Or from valley to valley, that's one period of the graph. So one thing, if you've been following along the last few videos, I've been describing how I'm not a big fan of the unit circle, although I have used the unit circle to find values of sine and cosine that put you right on an axis that you can't draw a triangle from. But what I want to just mention now is if you want to just do away with the unit circle forever and never have to worry about it again, then you have this option. You should know the graph of sine, and in a second we're going to talk about the graph of cosine. That is a graph you need to know how to graph when you go into calculus. So given that you need to know how to graph it anyhow, if you wanted to know the sine of pi and not think about the unit circle, you could just draw this graph and know that one period is between 0 and 2 pi. So if that's 2 pi, this is pi. And I can tell from this graph that the sine of pi, the value of sine when x is pi, is 0, just by looking at the graph. If I wanted to know the sine of 3 pi over 2, I already drew the graph, so I might as well just go back to this one. 3 pi over 2 puts you right in between pi and 3 pi over pi and 2 pi. So 3 pi over 2 is right here. And from this graph, I can see that the sine of 3 pi over 2 is -1. So that's how I prefer to think about it. So I don't have to worry about the unit circle anymore. If somebody asks me for the sine of 0 or pi or 3 pi over 2 or 2 pi, I just think about the graph and I don't worry about the unit circle, although it does work. So if you are a unit circle person, you like using that, that's totally fine. This is just an option. Okay, so now let's look at the graph of cosine. Cosine's graph looks very, very similar in that one period is between 0 and 2 pi, and it's going to go, the high is going to be 1, the low is -1, and the middle is still going to be 0. And now that we've seen how sine works, cosine is very similar, except the cosine graph doesn't start at the middle, it starts at the high. The cosine of 0 happens to be 1. And then once you're at the high, it's very much like sine. The next place the graph's going to go is to the middle at pi over 2, and then to the low at pi, back to the middle, back to high. So the graph of cosine looks like this. So there's 4 sections, right, for a cosine or a sine graph, right? 0 to pi over 2, pi over 2 to pi, pi to 3 pi over 2, 3 pi over 2 to 2 pi, which is kind of like the 4 quadrants, right, on the circle, from 0 to pi over 2, pi over 2 to pi, 3 pi over pi to 3 pi over 2, and then 3 pi over 2 to 2 pi. That's the way to think of a sine or a cosine graph. And same deal. Now that you know the graph of cosine, you should be able to reconstruct this at any time. And you don't even need the unit circle anymore. If I want to know, for example, what the cosine of pi is, I can look at this graph and see that the cosine of pi is -1. The cosine of 3 pi over 2, right here, the cosine has a value of 0. So I can now get these from the graph. Okay, so there's the graph of sine and cosine. Now let's talk about some variations of this, some transformations. For this one, we're going to sketch the one period of y equals 2 times the sine of x. And we've seen this kind of transformation before. This would be very similar to, I'll give an example here, like if the difference between graphing y equals, let's use the square root function, and y equals 2 times the square root of x. Square root of x graph, remember that one goes through 0, 0, 1, 1, 4, 2. So this regular square root graph looks like this. If I was graphing y equals 2 times the square root of x, all it's going to do is take my y values and double them. If I plug in 1 now, I get the square root of 1 times 2 is 2. Square root of 4 is 2 times 2. Now it's all the way up at 4. And so we've seen this before. When you put a number outside your function, you multiply your function by a number, this is going to cause a vertical stretch by a factor of 2. So what does that mean for a sine graph? Well, let's do this. Let's sketch regular sine so we can see the stretching part of it. So a normal sine graph starts at 0 at its middle, then at pi over 2 goes to high, back to middle, 3 pi over 2 it's at its low, and then back to middle. So a regular sine graph would look like this. But if I'm graphing y equals 2 times the sine of x, all that's going to happen is my y values are going to double. Double 0 is still 0, but at pi over 2, instead of sine of pi over 2 is 1, but now it's going to get multiplied by 2, it's going to stretch up to 2. Twice 0 is still 0, so it's going to go through pi comma 0. And at 3 pi over 2, instead of being -1, my y value is going to be -2. Put positive 2 up here. And then back to 2 pi, it's back at 0. So you can see it kind of stretches this thing out, right? And one way to describe it, really we only use this terminology for sine and cosine graphs. This amount that it stretches a regular sine graph up and down in this instance right here, we refer to that as the amplitude. And so we would say the amplitude of this graph is now 2. But the amplitude is just how much it stretches from the middle to the high and to the low. A vertical stretch with a 2 there means the amplitude of our sine graph is 2. Same thing would be true if I had a cosine graph. Here's another way we can translate or transform the function. Y equals cosine of x plus 2 now. Notice the plus 2's at the very end. And that's kind of, we've seen this before as well. That's like the difference between y equals, let's say, square root of x versus y equals the square root of x plus 2. What does putting a number outside the function do? Adding a number, that's going to cause a vertical shift. The graph of regular square root of x, we've already seen, looks like this, starts at 0, 0, curves upward. But all this is going to do is raise my graph up 2 units. So instead of starting at 0, 0, it's going to start at 0, 2, and it's going to be the exact same graph. Okay, so this is a vertical shift. This plus 2 moves my graph up. Vertical shift up 2. So the way I like to think about this for a sine or a cosine graph, I know that normally without that plus 2, my cosine graph's going to oscillate around the middle, which is y equals 0, the x-axis. But if I'm raising everybody up 2, that means my new middle is going to be 2 instead of 0. The amplitude is 1 because you can imagine a 1 there. So that means from 2, the graph can go up to a high of 3 and a low of 1. And it's the same 4 parts. So I like to start with pi, 2 pi. Halfway there is pi over 2. Halfway between pi and 2 pi is 3 pi over 2. A cosine graph starts at its high. So at 0, it's going to take on a value of 3. And then as we know, each time we move along, it's going to go, if it's at high, it's going to middle. By the time it's at pi, it's at low, middle, back to high. Something like that. Okay, so now we can put some of these things together. Let's look at the graph of y equals 3 sine of x plus 5. We now can identify the 3 as a vertical stretch, which is going to affect my amplitude. Sometimes we just use AMP. So my amplitude is going to be 3. This plus 5 is going to move my entire graph up 5. So the vertical shift is always going to affect your middle, which is normally 0. So this time for this graph, my middle is going to be at y equals 5. If my amplitude is 3, that means this graph can go up 3 units from its middle. So my high will be at 8. And it can go down 3 units. My low will be at 2. And we'll sketch it once again between 0 and 2 pi, 1 period. Sometimes it helps. If this is helpful, you can do this. Just draw like little, this is not part of my graph, but just help me to get a neat looking graph. I can put some little guidelines, I guess. Almost like when you were learning how to write lowercase and uppercase letters, you can make little guidelines here. Okay, my sine graph, this is a sine graph, so it starts at its middle and then goes to its high, middle, low, back to middle. In this video, we're only going to talk about amplitude and vertical shifts. Now, in the next video, we'll talk about horizontal shifts and changing the period of a sine or a cosine graph. So compressions and stretches horizontally. But we can also on this one pretty quickly talk about reflections. The main types of reflections we'll see for sine and cosines are when the negatives outside the function, kind of like negative x squared, where that takes the parabola and flips it upside down. It's just going to cause a reflection over the x-axis. So, but it helps to kind of see one first. So let's graph a regular sine graph, and then we'll graph the negative of it. 1, -1. So a regular sine graph would start at the middle, high, middle, low, middle. This is regular sine. But if I was graphing negative sine of X, it's going to start at the middle. This part's going to flip around the X axis. So it's going to go middle, low, middle. And this part will flip around the X axis and become positive. So here's the graph of y equals negative sine of X. Hopefully you can imagine the same thing with cosine. If you start with a regular cosine graph, which starts at high, middle, low, middle, high. Negative cosine, this part's going to flip. So it'll look like this. This part's going to flip. And you get this graph. So there's the graph of y equals negative cosine of X. One last example, putting everything together. If I'm going to graph y equals 7 minus 4 cosine of X, might be helpful to think about this as y equals, make that an arrow, negative 4 cosine of X plus 7, just to kind of see it in the order that we learned it. We can identify the transformations here. This plus 7 is going to move my whole graph up 7. The 4 is going to affect my amplitude. And we can see this negative is going to cause a reflection over the x-axis. Reflect over. How about I put horizontal axis? There we go. Gotta be a little bit careful. Because the proper way to sketch this thing is, let's talk about our y values first. So if our graph is up 7, that's our new middle. Middle is 7. The amplitude is 4, means from 7, the graph can go up 4 units. So my high would be 11 and down 4 units. My low would be at 3. Pi over 2. 3 pi over 2. I'll put in my little lines here to help me. Okay, but since it's a negative cosine graph, we see from up here, a negative cosine graph is going to start at its low, not at its high. So that's what I mean by I'm not really flipping it over the x-axis. It's just a normal cosine. If it was a positive 4 cosine, it would start here, but now it's going to start here. It's going to start at my low. Where do I go from low? I go to middle, high, back to middle, back to low. So there we go. That's not too bad, hopefully. Yes, and then make sure you watch the next video after this, where we talk about sine and cosines with horizontal compressions and stretches and horizontal shifts. Things get a little more complicated with those.